Chapter 1, Section 7 is simplifying expressions, and I probably wouldn't write commutative properties of addition and multiplication or the associative property title. I'm just going to talk about it. If you want to write those down, you can. You might have to pause the video to keep up. But first thing I want to say is this commutative property, that's saying things like this. If you're doing the commutative property of addition, it's saying 2 plus 3 equals 3 plus 2. Or for multiplication, you could say 2 times 3 is 6, and that's the same as 3 times 2. So when you're adding two numbers or when you're multiplying two numbers, it doesn't matter what order you add them in or what order you multiply them in. Now, a couple things. One, you'll notice that this is just for multiplication and the addition. There's no commutative property of subtraction or division. For subtraction and division, the order matters. Two, how I kept it straight in my head, because I kept getting commutative and associative mixed up, is commutative, I looked at that word, it's kind of like communication. It's kind of like if one person talks to another in a conversation, then usually that other person then says something back to the first person. So I kind of looked at communication. Commutative is kind of like the back and forth property. The associative properties of addition and multiplication, that's kind of like in a social group changing who you're hanging out with or who you're associating with. So if we have now three numbers, numbers 2, 3, and 4, it's kind of like if you put parentheses around the 3 and 4, it's kind of like they're a group, they're hanging out, and 2 is kind of on the outside. And the other way to write that with this associative property is saying, well, if I were to do my 3 plus 4 first, get 7, add 2 to that, I get 9. You should get the exact same answer if you add those things in the other order. So now if I have my 2 plus 3, if I do that first, I get 5. Add 4 to that, I also get 9. So associative property is saying it doesn't matter what order you combine things when it's all addition. And the same is true for multiplication. If I do my 3 times 4 first and get 12, and then multiply that times 2, I get 24. I'll get the same answer if I do 2 times 3, 6, times 4, gets me my 24 again. So when it's all addition or all multiplication, you can change the order that you combine the things in. Or you can change, like, associating. So if you have your three people, here people 3 and 4 are hanging out, person 2 is kind of on the outside. Here person 3 now is connected with person 2, they're hanging out, number 4 is on the outside. You can change associations, which is then kind of like the associative. So that's how I kept them straight. What would I write for sure if you didn't write that stuff? I would write this here. I'm going to put it in red for dramatic emphasis and say, in problems with all multiplication or all addition, so in problems with all multiplication or all addition, I'm going to do a colon and then say two things. My first thing is going to be that commutative property, the 2 plus 3 equals 3 plus 2. I'm going to say you can switch the orders of the numbers. You can switch the order of the numbers. And you could write commutative after that if you wanted to. But essentially I'm trying to say like this here, 2 plus 3 equals 3 plus 2, 2 times 3 equals 3 times 2. And the second thing, the associative property, is you can switch the order that you combine them in. So you can switch the order you combine them in. Or combine the numbers in. So if you remember this stuff here in red, that's kind of the commutative property and the associative property put together. And we're going to start seeing this type of stuff showing up in homework. If you didn't copy down those examples and you want to make your notes a little more clear, you could maybe just squeeze in there something like 2 plus 3 equals 3 plus 2, or 4 times 7 equals 7 times 4. And do that same thing for number 2. Maybe pick something like the 2 plus parentheses 3 plus 4 equals 2 plus 3 in parentheses, plus 4. And if you want to do the same for multiplication, you could. 2, 3 times 4, and then parentheses 2 times 3, and then times 4. That would probably help make it a little bit more clear. The next thing I want to go over is combining like terms. So Roman numeral, I'll probably just call it Roman numeral 1. Combining like terms. You could make it a different Roman numeral if you wrote some of that commutative and associative stuff. Combining like terms. And I'm going to break this up into two parts. First, I'm just going to look at addition and subtraction. And I'm going to write out kind of like what's the rule first, and then we'll go and look at how that applies to a bunch of examples. So I'm going to say, in order to add or subtract terms, in order to add or subtract terms, the variables must be exactly the same. So the variables must, dramatic emphasis, be exactly the same. And if that's not clear right now, hopefully some examples will really help make it clear. So I'm just going to list a bunch of examples. My first one I want to say is 4x plus 5x. So 4x plus 5x. Each of these like clumps here, the 4x and the 5x, are both considered like a term. So this has two terms, or kind of two parts to the problem. And if we look at those, they both have the exact same variables. The 4 and 5 are different, but they both have an x. But since the variables are the same, you can't combine these and say, I have 9 x's. And it's kind of just like saying, well, I have 4 x's here. I'm adding 5 more x's to my pile, and then that's going to give me a total of 9 x's. Another one you could do would be to say, all right, if I have just 4x now plus 5, can we combine those? I have 4 x's, I add 5 of something to it. It's not 5 x's anymore, so this here you can't combine. Or to look at what I wrote up above in the blue, the variables must be exactly the same. Here I have this x, here I don't have an x, so because of that I'm not able to combine those two things together. It'd be kind of like this. If we did different letters in there instead, if you have 5a, let's say A stands for apples, and you add 3c to it, C is carrots. Well, if you have 5 apples and 3 carrots, you can't say you magically get 8 applets. You know, you just can't combine them. So can't combine. All right, if I were to do this one here, say a 3x squared minus an x squared. So this one here, variables are exactly the same. Both of them are an x squared, or an x times an x. Now, no numbers written in there. So if no numbers there, you can assume it's going to be a 1. And then if I have 3 of the x squareds, I take away 1 of the x squareds. I'm going to be left with 2 of the x squareds. So 3x squared minus x squared is 2x squared. If I change it a little bit on you and say let's say I have 4x take away 5x. Now that one, we can combine them because the variables are exactly the same. So we know we're going to have a certain number of x's over here. Then you just look at the numbers and say, all right, it's really just a 4 minus a 5. And 4 minus 5 gives us a negative 1. So you could view it as though there's negative 1x right there. But when you have a 1, it's simplified if you don't put the 1 in. So the correct answer would just be a negative x. That'd be the best answer right there. And last one is if I have an 8x squared plus 2x. Might be tempting to say you have 10 of something, but this here you can't combine. Because 1 is an x squared and one is an x, the variables aren't exactly the same. So combining like terms, when you have addition or subtraction, you have to be exactly the same variable. Now letter B is multiplication and division, and these aren't nearly as picky. These you can pretty much just kind of cram things together. So I'm going to put a little asterisk and say you can multiply and divide terms with different variables. So those examples that we looked at before, those are going to work even if the variables are different, if it's multiplication and division. So if I have a 4x times 3, what happens is you're looking as though you just multiply the numbers together, multiply the variables together, and you get your answer. So I have, technically, it's going to be a 12x. If that's a little confusing, maybe apply that commutative property that we did earlier. That I could view this as though it's 4x is really just 4 times x. I could take and put a multiplication in between numbers like that. And because it's multiplication, that commutative property applies. I can change the order. So it's really just like a 4 times 3 times x. And the 4 times 3 gives me my 12. And then you just have x times nothing. So the x just kind of tags along. If we were to do another example, I'm going to have a 6x times 2x. So you multiply the numbers together, 6 times 2 is 12. Multiply the variables together and you get x times x, or x squared. And 12x squared would be your final answer. And again, if you wanted to, you could say, well, commutative property applies. Those are all just multiplication. Change the order. 6 times 2 is 12. X times x is x squared. If I were to have a next example of 8x divided by 4, we can still do the division even though there's not an x in the denominator. And you combine the numbers. So 8 divided by 4 is a 2. And x is not divided by another variable, so we just have a 2x. Last one like this I'm going to do would be 9x divided by 3x. And for that we do the 9 divided by the 3 gives us 3. X divided by x, well those just cancel out. You can cancel them. So final answer then would be 3. Final answer would be 3. What I maybe should do, see if we have room up here at the top. Don't really have room at the top. I'm going to say in here, combine the numbers and variables separately. So combine, or maybe combine numbers with the numbers and variables with the variables. Because you really just treat these problems kind of like two separate parts. Figure out the number, figure out the variable, and you're combining them. Now the one thing you need to be a little careful of is when you have like an x squared, I guess I don't have any of my examples. If I were to have, let me slide down here, one last example. If I were to have like a 13x squared times a 2x, then you would just do 13 times 2 gives a 26, and an x squared times an x, well that becomes an x to the third. And we'll talk about that more as the year goes on, but it's kind of like x squared is x times x. And then we have this multiplication right there. We have one more x. X times x times x gives the x third. We're getting close to being done. Last thing I want to hit is the distributive property. So Roman numeral 2, distributive property. And this stuff here, and those combining like terms like we were just doing and multiplying and dividing, those are going to be things that keep coming up as the year goes on. So best to master them now. If you're struggling with it, definitely hit me up with questions. But distributive property, technically it starts out, says for all real numbers a, b, and c. I'm just going to start by writing my numbers. But distributive property shows up when you have a number times, and then in parentheses you have numbers that are added or subtracted. Now when you have that combination, addition or subtraction in the parentheses, and something outside it times it, you have to do distributive property. And I'm kind of a visual learner, so I just always kind of viewed it as though it becomes that it's the A times the B and the A times the C. So this ends up equaling A times B, or AB, plus AC, or A times C. But that's kind of what distributive property is. I want to do two examples, and we'll kind of wrap up by doing those two examples. And hopefully that'll kind of help show like what we're doing. So my first example, I found most people get ones like this right, and then I'm going to take and kind of slip a little thing in there for the second one. So if I have 5 plus 2 times x minus 7. One way to kind of look at this, and why do we have this distributive property, is when we do these problems, we need to do order of operations. So we do please excuse my dear Aunt Sally. So we have to do the parentheses first, and then once we're done with the parentheses, then we do exponents. Then multiplication, division, you work left to right. Addition, subtraction, you work left to right. And so we start out here with the parentheses, so I'm looking at this here. Now the problem is I can't actually subtract this. Like we were just talking about, they don't have the same variables. This doesn't have an x, so I can't do the subtraction there. And that's why we have to end up doing distributive property. So when I do this distributive property, I have my 2 times x and my 2 times a negative 7. And technically, that's a positive 2. The sign in front of a number always goes with that number that's behind it. So when we do that, we get a 5, and then positive 2 times, right here I have a positive 1x, and that gives me a positive 2 times positive 1 gives me a positive 2, and then I have that x there. Now I do my positive 2 times, right here I have a negative 7, gives me a minus 14. Now in looking at this, what do we do next? It's all adding and subtracting, so we're down here on this step of our order of operations. And in that step, we work kind of left to right, but we can't combine the 5 and the 2x because there's not an x after the 5. They have different variables. But if we combine like terms, well, I have my 2x. We'll do that first because typically you do terms, clumps that have a variable. You do that first. And now I can take and combine my positive 5 and my negative 14. So positive 5, take away 14. Start out positive on the number line, you go left 14, ends up getting us all the way down to a negative 9. So the final answer would be 2x minus 9. Usually that goes pretty well for people. I'm going to make one change, and I'm going to have it look pretty much like the exact same question. But if I have a 5, now a minus 2, and then an x minus 7. And the thing that I put up here in green is really what people miss. Usually they just do 2 times x and 2 times the minus 7. But you need to look at this number here. When it's a plus, it doesn't matter, but now that we have a minus, it is going to matter. So I need to take and do my negative 2 times x, and a negative 2 times a negative 7. So I get a 5 minus 2x, because negative 2 times a positive 1x gives me negative 2x. Negative 2 times a negative 7 gives me positive now 14. And now, for my very last step, I can combine like terms. So I have this clump here. There's nothing else with an x, so that goes by itself. And I can take this and this. They both don't have x's, so we combine them together. A positive 5 and a positive 14 gives me plus, or positive 19. So my problem becomes negative 2x plus 19. That's it for the notes. Like I said a moment ago, if you're struggling with this distributive property or combining like terms, please ask, because it's something that is really important as we go on throughout the year.